Hello, this is the course for RTL design of FPU CPU. In this course, we're gonna make a CPU for Fenerbahce University that do the simple calculation. Designing a process capable of executing 10 different machine language operation codes, which contain introduction. That in the introduction, we just know that we have some register transfer level, and for the CPU design, we have a various code fragments that will be written in machine language. And at the end of the project, with the RAM control unit and register, we will make a simple processor and we will execute the program that we want. The tool that we are using in this project, one of them is phenomenal simulator. I don't know if I pronounce it right or wrong, but phenomenal is a simulator used to visualize the architecture of the CPU, especially for Fenerbahce, and observe the data flow. And also, we're gonna use the Vivado design. Vivado is an application that you can write your code and see the execution of the language of hardware. The objective is to execute commands as per the specified conditions. In this graph, we just try to know that from first 0 step what we're gonna do till 4 step. This graph will show us the mind mapping. Like before every project, we should do that and see what we're gonna do and what we're gonna write in the project, what we needed, what necessary condition that we want. This is a design of our processor. We just design our input and we realize what input we want. For example, in our input we want keyboard, mouse, scanner, these, and we divided memory in two parts. We have a processor unit which is in the center. We have control unit which contain PC and IR, and our output is actually monitor and printer LED disk. The design comprises 4 storage units. One of them is status registers that holds information about the current state of the state machine. And the second one, which is PC, which contains 6 bytes, determines which commands from the RAM will be fetched and what kind of that 6 bytes correspond to the 2 to the power of 6 location in the RAM. And it actually allows the PC value to address every location in the RAM. The third one is IR. IR contains 10 bits, and IR is actually the instruction register which is storing the instruction read from the RAM. So IR will always read the instruction from the RAM. ACC, which is contain 10 bits like IR, it's an accumulator, and it's kind of a storage unit for holding arithmetic operation result. And we have always block here, and all other storage units will operate based on changes in the state register. And the input signals for all storage units change according to the value of the state registers. The memory signal connected to the input-output ports in the diagram are as follows. We have 4 different diagram, which is for our input and output ports. The first one is MAR, which contains 6 bytes. And MAR is a memory address register, and it's for storage units linked to the address input of the RAM. And it's also said that it is 6 bytes since RAM has 2 to the power of 6 locations. MDRLN, which is contained 10 bytes, memory data register is a storage unit used when writing data to a RAM. It's also 10 bytes. It's more than MAR to match the size of RAM's locations. The third one is RAM WR. which contain 1 bit, like less than any other input and output, which controls the writing of data to a RAM, and it activates when it sets to 1. When not active, it's actually 0, and the data is not written to the RAM. And this control is within the RAM. It's all of the work of RAM WR is in the RAM. MDR out is 10 bytes, is a memory data register, and is a storage unit, also like MDR in, which is the input, and this is the output. When reading data from RAM, it's 10 bytes to match the size of RAM's location. This register is within the RAM, also like MDR. And these codes here are all contains operations, and in the design the necessary storage units connect to the input output ports, and we define this code as follows. RAM is a random access memory. FPU CPU has a storage units and a clock signal connected to the RAM, where it reads commands, performance, calculation, and write back to compute value. This is a table, this is an instruction that you can use in Phenomenal. The table at the right is the instruction for the simulator that I show you a few minutes ago. And all of the instructions just written here, you can check it out. This is a state 0, which we define a case, and we begin and we equal MAR to PC, and we equal 0 to RAM WR, which is right, and we +1 the state. We also begin another thing that you can check it out. This is the state 2. Okay, the test bench software is used to verify whether our design project is functioning correctly or not. These are the state that you can check your function. The codes in the FP CPU and memory files have been defined as shown below, and the signals of both are interconnected. Our input and output all defined here that you can see it. And now we can examine the application that for test cases in test case stores the sum of two numbers at address 50 and 51 in memory into address 52 for the FPU CPU. And now we can examine the application that for the test cases in test case LV stores the sum of two numbers at address 50 and 51. Now we can see the result in a different way, in a signal way that our synthesizer shows us in Verilog application. In conclusion, when the developed FPU CPU processor meets the necessary condition, it can execute 10 commands and perform 4 operations. Regarding the achievement gain, we obtain information about the register, memory, arithmetic logic unit, and control unit necessary for this process. Thank you so much for watching the video. Please don't forget to subscribe, and wish you best.